Welcome. Let's look at rational exponents. And first, we're going to look at the different forms of these. So notice this one has a fraction exponent, and this one has a radicand. That's the square root symbol, but here it's a fourth root symbol. So the first thing is simply changing these. So 49.5 is actually the same as the square root of 49. That number at the bottom here, that denominator, is the root. We also call it the index. In fact, index is a better term to use for that here, because the index is usually written here in the root symbol, except for twos, we don't usually do that. That's we have to do it for the others, but if it's not a 2 there, it's understood it's always a 2. So in this case, the square root of 49 is equal to 7. Now, it's plus or minus 7, but in these sections, we are using what's called the principal root for squares, for square roots. That means we're only using the positive. So that means 7 is the answer for this one. On the other one now, so what we did here first, actually, let's come back to it. We changed from this form to that form. Now we're going to change the other way. We're going to change from the symbol, the root symbol, the radicand form, to the fraction form. And that means we're going to go opposite. Here we took the 2 that was the denominator and made it the index. Here is the index. And so what we're going to do with this one is make it x with that index on the bottom, and the 8 inside goes on top. Well, that means we can cancel there, which is 8 over 4, which is 2. So that's the answer to this one. You could have recognized that if you thought about the fact that the x to the 8th is x squared 4 times. And so the exponent of 4 and the fourth root cancel each other out. Or rather, you could say there's a full entire x squared that comes out to the front of it, and there's nothing left inside. So the lesson here on these first two problems is simply that there's just different ways you can write it. It's the same thing, you rewrite it a different way, and sometimes that means you can do something with it, like the B problem, okay, and the A problem, both of them actually. So practice these two here. Do them yourself, and I'm going to do them in just a second here. All right, this first one, that 3 means it's a cube root of 8. Oh, and now that means we can look at that and realize 8 can be written as 2 cubed, which means it's just 2 is the answer. Just like as if it was the square root of 4, it would be 2 squared, and things would cancel, and we'd have just the 2. On the other problem, we're going to do the same thing, a square root of x to the 6th. Oh, no, I did that wrong. It's a 6th root of x squared. See, what I didn't do here, I actually got myself mixed up. I just wrote the same thing. I'm just going to take this and make it the fraction underneath it. So it's x2 to the 6th. Now I've got that right, which means we can make it a simpler fraction, 1 over 3. And so it's x to the 1/3 for this one. Now, let's look at some where there's going to be something left in, or let's see. We're going to do them where there's both a denominator, numerator and denominator. On these others, we didn't have that until we were canceling them out. Well, let's do these for practice, see what happens. So this first one, cube root of 27 squared. Now we're going to have to play with those numbers. And the second one is the fourth root of 16 cubed. Well, let's rethink about what 27 is. 27 could be seen as 9 squared. Or so we can see it, oh, not 9 squared, it would be 81. So actually, I'm thinking it wrong. We can see that as 3 to the third power. I was thinking of 9 times 3. So 27 is actually 9 times 3, which is 3 times 3. That means we have 3 threes. So if we write it as 3 to the third power squared, we could write that as the cube root of 3 squared. 3 to the sixth power. However, let's think of this. These two, because 3 times 2 equals 6, you could do it as 2 times 3 equals 6. Now notice that the index and the exponent are the same. That means this 3 squared here can come out from inside the radicand. It can go to the outside of it. And if it goes to the outside of it, that means that it is just simply 3 squared as the answer. So this problem required taking this number and rewriting. The pen is not cooperating. Let's see if I can get it now. Rewrite it. Now let's look at this other one over here, and there's actually two ways to look at doing it. One of them is easier than the other. Everyone recognizes that 16 is 4 squared, so I could do that. But it will actually be easier if you also start to recognizing numbers like 16 and 32 and the others, and 64 as a 2. This would be 2 to the 4th power cubed. And now we have a situation just like over here, where I can reverse these, because 4 times 3 is 12, 3 times 4 is 12. It doesn't matter which one comes first if it's multiplying. But by doing it this way, having the 3 there and the 4 on the outside, that means we have the index and the exponent the same. So the answer is simply 2/3. There's nothing left inside the radicand, so that's it. The other way could be done too, but it requires some more changes of things. 4 squared to the third, I'm going to do is 4 to the sixth. Then that's going to be 4 to the fourth times 4. This 4 then, because the index and exponent are the same, can come out there. And so we have the 4th root of 4. And then, let's see. Oh, this is 4 squared. I forgot. That's 4 squared there. So now what we have, 4, that's because 4 plus 2 makes the 6. So next what we have is 4, 4th root. That's 2 squared squared. 4, 4th root of 2 to the 4th. 4 times that 2 comes out. Okay. So we could make that 8, which equals 2 cubed, which is, well, we got the other way too. So 2 ways to do it, but this one certainly involves more ways, more things to do. Definitely easier to do the 2 to the 4th power. Now let's solve some of these. Solving exponential equations. Here's what we do. The basic concept is if you have the same exact base, then the exponents are equal. Take, for instance, well, x to the third power is equal to x to the y. What's y? Well, these are the same, so there's no question that that y has to be 3 in order for these to be equal. But this 16 is not the same as the 2. However, you are able to rewrite the 16 as 2 to the 4th power, and because these are the same, you can now say that x is equal to 4. Relatively easy thing, except for recognizing what that is. Now let's look at B, where we're going to add something to it. We're not just going to have x, we're going to have x plus 1. But the 27 can be written in terms of the 3. And that's the thing you want to do. You want to think, how can the 27 be written so I can have the same base of the 3? On the first one here, that's what you want to think for the 16. How can I write that so it has a base of 2? Now, because these two bases are the same, that means the exponents are equal. X plus 1 is equal to 3. Subtract 1, x is equal to 2. So if I were to put that 2 back in here, I'd get 3, 2 plus 1 is equal to 27. That's 3 cubed, and 3 cubed is indeed 27. So that checks out pretty well. Could have done the same thing with the 4 here. Put 4 in here for the x, and yes, 2 to the 4th power is 16. Now, for C, it's the same concept, just a little bigger numbers, the same thing with D. In fact, I recommend that you try to do these yourself right now. Pause and come back to it and when you finish them, and I will start doing them. Welcome back. Well, I'm going to look at this as 8x to the minus 1. And if I play with the calculator a bit, I can find that 512 is equal to 8 to the 3rd power. So because the 8's are the same, I can say the exponents have to be the same. And so x is equal to 4. If I put it back into this thing, I would have 8, 4 minus 1, which would be 8 to the 3rd power, which indeed is 512. Okay, like that. I'm going to mark up my answers here so it's clear what they are. So for C, it's x equals 4. Now, there is something you could do that's different. 8 also happens to be the same as 2 cubed. So I can do, instead of 8, I can put 2 cubed x minus 1. And then 512 just happens to be, if you play with it and do 2 a bunch of times, is 9. So now what I see, since x minus 1 is the exponent of 3, I have 3 times x minus 1 equal to the 9th. 3x minus 3 equals 2 to the 9th. Because these are both 2's, I can make the exponents equal. Add 3, 3x equals 12. Divide by the 3, and x is equal to 4. And, oh, we get the same answer. This is a little more complicated. So if you can make one of the numbers that's already there be the base of the other, that's probably easiest to start. Okay, now, sometimes you can't do that. We'll get to that in another problem later. Right now, let's see, do I want to do it with this one? I guess I do it with this one. 16 raised to a bunch of powers does not make 16, 3, 8, 4. So what we have to do is think what makes up the 16. We have 2 to the 4th power, and we have 4 to the 2nd. Let's try with 4's. If this is 4 to the 2nd power, I think I want to put this one in blue to make it a little different there. 4 to the 2nd power to the 2x minus 5 is equal to, well, if I keep playing with this one, I end up with 4 to the 7th power. If I didn't get that, I would try something different. I would try with 2's instead. I would have seen if 2 would have gone into it, and it would have actually, and I could have done it that way. But now we know that the 4's will work. But here I have to do 2 times 2x minus 5 equals 4 to the 7th. So now I can work that out down here. The exponents are equal to each other because the bases are the same. That's 4x minus 10 is equal to 7. 4x equals 17 when I add 10 to both sides. And when I divide by 4, I get x is equal to 4.25. I can make this one a decimal because it ends there. It doesn't repeat, and it doesn't go on as an irrational number and never end and never repeat either. Now, if I put 4.25 into here, I would get 8.5. 8.5 minus 5 is 3.5. So I get 6 to the 3.5. I believe that would be right. Actually, let's see now. 4.25. That's 8.5 minus 5 is 3.5. Put that in the calculator and you get 16,384. So here we have 4.5 there. 4.25. All right. So this was one where you had to change both of them. Changed both. Didn't have to do that with the others. It was okay to change both on C, but you didn't have to. On this one, you do have to because 16,384 cannot be written as 16 to a power. except the decimal, the 3.51, but you wouldn't know that yet. Okay. Now over here, we'll look at this, do the same thing. 16 raised to a power that's not a decimal doesn't become 1084. But 16 is 4 squared. It's also 2 to the 4th, but I also know that I can do, let's do the x plus 2 here, is equal to, I'm sorry, that would beat that. The 1084 can be written as 4 to the 5th power. So now I have 4, 2, x plus 2 is equal to 4 to the 5th. And these exponents are equal to each other. So 2x plus 4 is equal to 5. Subtract 4. 2x equals 1. X equals 1/2 or 0.5. And if you put that back into the 16, 16 to the 0.5 plus 2, 16 to the 2.5. If you do 16 to the 2.5 in the calculator, you will get 1084. Make that a better one, and then yellow this one out. Identify. This next one, if you played with the numbers, you'd get 3 squared, x minus 2, and 2187. Well, 9 to a power doesn't go into it, but 3 does. That's 3 to the 7th power. So now we have 2. Now, because the 3's are the same, we can work with these exponents. Make them equal to each other. 2x minus 4 is equal to 7. 4. 2x equals 11. X equals 11 over 2, or 5.5. 5.5 is probably the more common answer. That would be. If it doesn't say, you can put it in fraction or decimal form as long as you don't have to round. Okay, if you have to round, then leave it as a fraction. So if this had been 11 over 3, we would have had 3 2/3, or 3 2/3 would be okay, but 3.6666 or 3.67 would not be acceptable. You have to have an ending that the decimal ends and doesn't repeat. Well, that's pretty good for solving these equations. You see now what to do, where the idea is you have to get these two numbers to be the same. And sometimes you have to change them so that they're the same number, but you have to change both of them. Okay, and that's pretty much what all of these are. Notice also, especially when you have an exponent times an exponent, you multiply them. And you multiply them even if one of them is a binomial. Okay, that's all for this now. Thank you for watching, and I hope it was helpful.